With great data comes even greater access latency. Welcome to the Trino Community Broadcast, where we transform your latency woes into fast insights. Trino Community Broadcast is a show where we cover events and happenings in the open source Trino community and show off some really cool stuff about Trino, and today, Resurface. So we have a couple honored guests today. Rob, thank you very much for joining us. And returning to the show today is Martine, the CTO and creator of Presto and Trino. So welcome, everyone. And
thanks for having me.
Yeah. So
Right.
going to be jumping into some pretty cool stuff. Rob is maybe I don't know if you do my job better than I do about talking about Trino. I think you're I would say one of the biggest super fans that we have in the community, and we're so glad to have you today. It's pretty cool whenever where you are in you basically have this technology that is used in a particular way, and then you just you get a use case, and particularly like how you guys have started to integrate Trino into your solution. It's really interesting to hear, and so that's kind of what we're going to be talking about today is kind of understanding what Resurface is, what you all are setting out to achieve in your company, and then kind of see how Trino crept into that solution that you all are providing. So we're really excited to hear about that. But first, let's go to talk about our sponsors of the show. We are sponsored by Starburst, and basically, we just wanted to do a quick talk about one of the meetups that they will be sponsoring. Let me go quickly to that in the code scene. So Starburst sponsoring this meetup that we have on May 26th. And this is going to be inviting one of the guests that we had on the show. I think, was it two episodes ago?
2 episodes in.
With Ryan Blue. He is the creator of Apache Iceberg. And while we were talking about the Apache Iceberg in general, we ran into we just kind of on the side asked him, like, are there any kind of interesting use cases that came up with Iceberg that were kind of like the out of the ordinary type of use case? And Ryan just started spouting out, like, I mean, 3 or 4, and he could have kept going. And I was like, man, it was so interesting, and it pulled us over even longer than we usually go. But it was so worth it. It's like, so I was just like, I invited him to see if he could come to a meetup and talk about like all these crazy use cases, and actually just dedicate a whole talk to it. So Ryan is going to kind of come on and talk about, I think, Iceberg in general, just for anybody who doesn't know about Apache Iceberg. It's super cool table format that replaces a lot of the setup that Hive has, the Hive table format was using in the past, and solves a lot of issues for data engineers. And so after he kind of talks about that a little bit, he's going to go into some of these like really interesting use cases. And one of the particular ones I thought was interesting, I'm not going to get to spoil it totally, but it kind of replaces one of a Hive topic. So you could actually use Iceberg to kind of replace one of the uses for Hive topics in certain cases. So really interested to hear about a lot of these, and definitely come sign up if you have not already. It will be in, I think, just yesterday, 2 weeks from yesterday. So about 2 weeks from now. So come join us for that. This is sponsored by Starburst, and really excited to have these things coming up. This will only be in the Americas, by the way. We will be taking the recording and putting it up for the other time zones, but we are now trying to push a little more towards having the time zones, the different meetups in different time zones kind of have their own local speakers as well. So, but anything that happens in any of these will be recorded and then made available to anybody from any time zone. So try to make it if you can, if you're not in the America's time zone, and otherwise we'll have it in a recording for anybody in EMEA or APAC that's not available to attend.
And let's use that as a call out straight away right there, because
True.
if you are interested in presenting at the Trino meetup in Asia Pacific or EMEA or even in the US, and you think you have a great topic, please contact us and we'll make it happen.
Yeah, we're getting different people in the community, who some different motivated folks in different areas that are going to be kind of stepping up. We're hoping that we'll slowly kind of get them to step up into these leadership roles in their particular regions, and then they will be kind of running these shows and looking for people. But definitely, if you are somebody who has something interesting to talk about with Trino, or even if it's just like kind of talking about how your company uses Trino, we're always interested to hear those different talks that could be something that who knows, eventually makes it into something like we can try to get you into Trino Summit or something like that. Which we will talk about right now, since I already brought it up. Trino Summit. Oh man, I didn't even put it on the events. Here, let me just go to the website real fast. Trino Summit. Here we go. So starburst.io. This will be in the show notes after this. So you go to starburst.io/Trino Summit 2021. And we will be having a summit on September 15th. Originally, we had planned 2 days, but we decided this is going to be moving to a hybrid event. And so we are going to be making it a single day event for the safety of those attending in person. So right now we are just having a save the date. It's kind of early to register since this is so far out, but we will be moving into a registration in a couple months. But just wanted to keep people aware that this is coming up, and we have a lot of interesting talks already kind of planned. And as of course, Martine will be and Dane and David will be delivering the state of Trino. So without further ado. I was gonna, before we hop right into everything else, I guess we didn't have a release this week, huh?
No,
we had one last week.
We actually jumped ahead of time, and we actually talked about 356 in the last show. And I don't know if we were like expecting, I don't know what we were expecting, but I guess we just knew that, yeah, we weren't going to be able to get a release this show. But is 357 coming up anytime soon, or?
Probably like in the next week to week and a half or so.
Okay. So maybe, we're doing the show. Typically we do the shows every 2 weeks, but this show we're actually going to be doing, the following show is going to be in a week. So it'll be anybody's guess if we'll have 357 to be reporting by next week. So, okay. Well, so that's just so everybody knows that listens to this usually. We did cover 356 last week. We will be having nothing to report on in terms of releases this week, but a lot of cool stuff I've already seen kind of queued up for the next release already, including Manfred was just talking about a couple docs changes coming down the corner. So that's always exciting. So, all right. So the theme of this show, let me go over to the code scene real fast. We have our traditional Commander Bun Bun rocking the theme of the show. So here we see Commander Bun Bun on the Resurface whale logo. And by the way, today I'm also kind of sporting not my traditional Trino shirt, but I'm sporting a Resurface haiku shirt. So it says, "My API broke, used to work just fine, and now I'm dying inside." So nice little haiku. Who thought of that haiku? Is there a big haiku junkie at Resurface?
Oh my gosh, was that our April Fools? I forget. We were having a haiku contest on Slack at some point.
Oh, nice. And this was the winner?
Yeah, I think that was the one we actually tweeted.
Very cool. Very cool. So yeah, today's guest, Rob Dickinson, you're the CEO of Resurface and co-founder of Resurface Labs. Can you tell us a little bit about Resurface and kind of, what kind of problems are you all solving over there?
Yeah, and thanks so much for having me. I mean, we are super fan is the right word, totally, when it comes to Trino. So Resurface is an API system of record, which is just a fancy way of saying that we're a database that's specifically built to deal with API requests and response data. So we're capturing API traffic, and you can think of that kind of like a weblog or an access log, but on steroids, because Resurface runs on Trino. And so you have a weblog or an access log that has all the details, and you can manipulate all that data with the full power of SQL that we get from Trino. So it's really, an amazing mixture. There's a lot of NoSQL things out there and custom built things out there, but to actually be able to present all that data through a standard SQL interface, I think is pretty unique and amazing. There's a lot of tools built on Elastic. There's a lot of observability and logging tools out there, but as far as I know, we're the only one that really could be called Trino native.
Yeah, so you were talking about kind of observability and logs and metrics. Now, like a lot of people, like the first thing that came to my mind whenever I was reading through kind of the problems that Resurface is addressing, sometimes it might easily be confused with like a typical observability or telemetry type service. That's not what you all are doing here, though. It's very different. What does Resurface do that kind of differs them from that type of space?
Yeah, so our goal is really to help you instantly find API failures, slowdowns, and attacks.
Okay.
And so we're thinking about that from really a DevOps perspective, from a DevSecOps perspective, and what we've seen over and over again over the last 10 years with our previous company and now with Resurface is just all these cases where you're using system monitoring. You're looking at the health of the systems. You've got your logs, you've got your health metrics, and those are telling you, your CPU looks okay, and your processes are running and things are available. But there's still a gap between that and what your users or your customers are actually seeing. And from our own data, our estimate is that if you put an API service up and you make it public, anywhere from 1/3 to half of that traffic that you're going to get is not real. It's bots, it's attackers, it's people trying to probe you, trying to figure out, and kind of the larger target you are, if you're a bank, if you're an e-commerce platform, if you're a crypto platform, I mean, you even present a larger target for all that. So one of the symptoms that we've seen from that is you might look at your system logs, you might look at your system metrics, you might see that there was a 500 thrown, or there was a stack trace that shows up in your logs. And then your first question is going to be, well, is that really something that I care about? Like, what's the urgency? Has that been happening a lot? Was that a script kiddie just knocking at the door trying to get into doing something stupid? Or was that a real customer that actually lost revenue? Where I should go back and re-engage. And we've seen kind of this breakdown that we see in this diagram here. I mean, this really isn't that new, right? I mean, if you think about like how Apache web server runs, you've got the system log messages, and you've got like the system health that you can manage, that you can monitor out of Apache, but then you've got your weblog, and those are really separate concepts. And so that's really how we're positioning Resurface. Is we want Resurface to be the easy way to plug in, and now you've got that weblog like functionality, but because it's SQL powered, you can do a lot more with it in terms of finding those failures, those throwdowns, those slowdowns, and the attacks.
Yeah, I like the analogy I kind of drew in my head, and just maybe this is totally wrong, but like the way I think about it is, like a lot of people that are putting APIs, like, APIs are these like public HTTP things that are easy to like call and manipulate and mess with, right? And it's like such an easy hole to poke through your system that potentially exposes a lot. So like a lot of times companies will do like pen tests before they try to deploy these APIs and make sure that like everything is good. and then they just deploy it. And, you know, again, you take system logs and things like that, but there's not a lot that's going on continuously on production unless something happens in kind of a reactionary state. And so I like to, I don't know if this makes sense, but like, would calling Resurface an ongoing pen test make sense? Like, it's essentially like, yeah,
absolutely. Yeah, absolutely. And we're really moving very, very quickly in that direction. So
cool.
It's not a stretch to say we're kind of like Burp Suite, but we're running continuously on an ongoing basis on your production systems. So we want to be because these are actually all things that you can query for.
Yeah.
You can query for SQL injection.
Yeah.
You can query for malformed JSON.
Yeah.
And actually being able to do that with a query first approach is exactly what you want, I think, for this kind of use case, because now if you find that 0-day failure or you find that 0-day attack, you can immediately back test that idea against all of the data that you have. And now you have a really easy way to find out, what's the severity, what's the urgency, is this a revenue loss event, or is this an attack that needs to be mitigated somehow?
Yeah, usually those classifications of what actually happened don't come until after your security comes in and investigates. Your security team comes in and investigates, and you're trying to kind of get ahead of that curve and basically say like, okay, this is what the I guess the fingerprint of this call looks more like this type of attack, and this is kind of how it's being classified. Now, is that classification happening through some smarts that Resurface has, or?
So you're absolutely right that the classification that we're doing is behavioral, right? Because hackers don't just identify themselves as hackers in their user agent string. Like it's not that easy.
Here I come.
Right. What you want to look for in the user agent string is known pen test tools, so that you can like take those out of your regular metrics, so that your pen testing doesn't mess up all your normal KPIs. But setting that aside, you're absolutely right that the best way to detect threats is what they're actually doing. Is your API being used in bounds? Is it being used the way it's supposed to be used, or is it obviously trying to be manipulated? And again, we're really taking a query first approach to that. We're doing just a bare minimum of processing actually at capture time. So we do just a couple things, like we'll parse the JSON payload if it's there and validate that. We'll parse the GraphQL payloads that are there and validate that. But almost everything else is done through views and virtual columns, which means that those definitions, great to go back to this. So a certain amount of this is coming, from the actual data collection, but then a lot of this is actually done with virtual views and columns.
Okay.
So super naive question. And so basically you're saying you expose some sort of business API, like typically, I guess, a REST API you were saying, you also mentioned GraphQL. And then what happens is Resurface sits between, like, somewhere between the business logic that implements and like listens to the API and the web server load balancer or whatever that hits the API, and you just take all the traffic and dump it somewhere in addition. And then you use Trino to query it and apply additional logic. Is that kind of how it works?
Yes, exactly. So a lot of solutions do this on the network. They do this by using gateway servers or proxy servers, or God help us, packet sniffers. That's old world, but we're taking a very user space approach, more like an App Dynamics or a New Relic. So we can either put middleware into your API, or we can hook your API gateway. Like if you're on Azure, we can hook into Azure Event Hub, just like everybody else. And that's what gives us the feed of data. And then what we basically have built is a native storage engine for Trino. So we're essentially like, there's some separate processing that we're doing outside of Trino on the ingest, but we don't really have a database. Like our database is Trino. We'll get to a diagram of this, but we're bringing all this data in. We're coalescing it into binary files, and then we're scanning those binary files with a custom connector, where we worked backwards from the Trino row set interface. So yeah, there should be more tools that are doing this, but as far as I know, we're the only observability tool that actually uses Trino as its native data store.
Very cool.
You were saying before that like up to 50% of traffic, typically of any like more or less public and popular API, is by some sort of hacking and like not valid traffic.
If it's an API or a web service interface that's at all attached to a website or discoverable that way, then absolutely, like at least 50% of your traffic will be garbage. And it's kind of a dirty little secret, honestly, in the APM community. We used to get this question all the time. I see the stack trace, but and I see there's errors going on, but is that real? Like, am I being spoofed here? Is it a DOS attack, or am I really losing revenue? And what really sucks is when you're in the moment of that, it feels horrible because you're guessing, everybody's running around trying to figure out what's going on. Your organization over rotates on it. And we hate that, right? We hate those escalations. Yeah. It's the opposite of being in a flow state and writing code.
Your Venn diagram here kind of summarizes that, right? By the way, I love your use of emojis in all of these diagrams. It's so perfect. But yeah, like this is kind of what you're suggesting here, right? Is these overlaps of responses failed. You're not really sure if that's due to some actual customer problem, or if it's actually, like people just spoofing or bots just messing around, kind of like randomly hitting ports and trying to scrape and see what's possible. So is it this, screaming customer, or is it this little devil guy down here? That's the question. And you don't know. You don't know it until you actually classify and actually start tracking the calls coming in and classifying them in some way.
Yeah, and again, it's that you're taking your system that you stayed up late and got working right on your systems and your test hardware and everything passes, right? Mm-hmm. But then you take that out into production, into this very hostile environment. Mm-hmm. And it totally shifts your perspective. And I think one of the ways that you see that is when you look at some of the messaging around APM and observability, there's this idea that we're gonna stop all the failures. You're gonna be able to resolve everything. And that like totally makes sense if you're in a controlled environment. But as soon as you go into a live public environment where like maybe up to half of your traffic is goofball traffic, mm-hmm. I mean, that just you're never actually reducing the number of failures to zero. You're just managing how your stuff is failing, because half the time it's being misused, and of course some of that you want to fail on purpose.
Yeah. It reminds me of this. You ever see the Dave Chappelle episode where they try to make the internet into like a real place, and it's actually like a shopping mall? And so like, we never think about the internet as like some very chaotic thing. Sometimes we go and we interact with it ourselves as a human being, but we don't see a lot of the, kind of nefarious or even just chaotic in general nature of all the different bots and different things that are going on. And so anyways, and for those that don't know, it's a comic little setup or a comic scene that they do where they go into this mall type thing, and they have places where you can actually buy, regular music, and then they across this is a long time ago, but across from the place where you actually buy the music, there's this place called Napster where everybody's just looting the store and pulling out CDs for free, and it's total chaos in this mall that they have called the internet. So it's exactly kind of what you're saying. We don't think about the internet being as chaotic or what's going on. I think maybe developers do, because we see a lot of what's possible, but your average individual that's thinking, okay, well, we're going to put this thing out there and it's going to be just like it was in testing. It's never the case, and like you said, it's a very hostile environment. So
this is why your security people are so grumpy.
Yeah, exactly.
Because they feel like they're under siege all the time.
Yeah.
And I think one of the things that I think we're really excited about is the idea that, if you go back to when DevOps was new, the coolest thing about DevOps was like for the first time as a developer, I might get invited to look at the production system. And so I'm not actually seeing how it runs on my system. I'm seeing how it really runs for real. And the ops team used to own that. And that used to be like somebody else's thing, right? And it wasn't like yours. You didn't just have direct access to it. And it feels like it's the same case with security today.
Yeah.
So if you think about like unless you're really looking at the same data and you're huddling around the same ideas, it's so easy to have the split brain that comes out of that. Like development thinks everything's fine, all our tests are passing, it all works on my machine. And then the security team is running around with their hair on fire, trying to build urgency, right? But as a developer, I've never been invited, like I've never been given a login to a SIM or like shown any of the security systems, even running on my own apps, right? Because it's heavily gated. So yeah, just that's really what we're trying to do is use the system of record to be able to bring these different stakeholders together and really say, let's stop guessing. Let's stop guessing about what the threats are. Let's stop guessing about how that's really affecting our APIs and really be able to take an empirical approach.
So there's a big list that you have here. And by the way, all these images that we're kind of referring to for those listening in these are all available in the show notes. So, so this big list of kind of fields that you have here, these are all things that either you've directly received from the logger or is somehow kind of parsed out and placed into the database. Is that correct?
Correct. So the biggest thing, if you're trying to get your head around, what we're doing and how it's different from logs or health metrics, it's really about the data model, right? Metrics are time-stamped counts. Log messages are time-stamped severity and a detail message. And that's one of the things that makes logs hard for non-developers to use, is because whatever question you're trying to ask, you have to translate to a detail message that you can free text search on. And it's not obvious how you would do that. Our data model is really, it's the HTTP datagram. So it's all the data in the request and the response, and it's all broken out into these discrete data elements, so that you can say, I want to do this with the path, I want to do this with the URL, I want to do this with the date or the headers or the payloads, and be able to address those different data elements individually. And then of course, be able to apply aggregations and filters and everything else that you get through SQL.
And this kind of gets pulled out into a query that may look like, this is the view, a query on that view that you were kind of discussing before, this query here.
Yeah, so the problem and what led us down this road with Trino, the problem is, like, it sounds great to have that data model with all those different fields in it. It's very rich. I can now describe a lot of different conditions, and I can relate those fields to each other. So I can do things like look at the content type, and if the content type is JSON, then I can try to parse the response body as JSON. So we're really trying to get into those deep level inspections, right? Because we're trying to identify threats, we're trying to identify soft failures where maybe you didn't get a 500, but there's a stack trace returned as the response. And the problem with that is, as you can see, like this is actually like the simplest query, still realistic query that I could come up with. Most of them are much bigger, but the problem is you're really touching all of those columns. So you're saying, I need to look at the response code, I need to look at the payload, I need to look at the content type, I need to look at the response time, you know, and then you turn around, and this is just for like the failures part of that. And then you say, well, let's subset that with the attacks. And the attacks is going to be a whole different set of conditions around what the URL looks like, what the response codes are, and so on. And it's much more meaningful if those aren't static, fixed definitions that are applied when the data is captured. Because the question that you really want to be able to answer is, what's going on right now? So being able to apply these definitions in real time or change these definitions in real time and have that instantly apply to all the data that's there, that's the kind of use case that we wanted to get to. But as you guys know, you know, if you try to, so then you step back and you say, all right, well, as a database designer, what kinds of indexes do I need? Wow, it sounds like I need an index on every column. And is my database going to do a great job of merging those conditions together if I'm literally constraining every column?
Yeah.
You know, with a columnar database in particular, that's actually one of the anti-patterns.
Yeah.
You don't want to try to rematerialize all columns, all rows at the same time. That'll be more expensive. So we really struggled to find a data store that would work for these kinds of workloads and really give us the efficiency that we were looking for.
Gotcha.
So you then ended up saying, we can't really just dump it into like Elasticsearch or some relational database and explode it. We can't store it as JSON files straight on Iceberg or Hive or whatever. So you had to bite the bullet and figure out how to do an actual storage engine like that. That must have been a big decision and a big call. What led you down that track, and then sort of what did you end up finding? How hard that is, and how much Trino helps you with that?
Yeah, you're absolutely right. It's a huge set of problems there. In our previous company, we took a star schema approach. We actually had we would evolve the schema to fit the data. We had multiple patents in this area. We spent years developing the stack. And honestly, my feeling was we couldn't afford to do all that again. Like it's a huge lift to try to do to try to satisfy this kind of query in a normal relational database. It can be done, but the mapping that has to be done to get that to work is pretty extreme. And it's also pretty sensitive to the data and the distributions in the data itself. So what we actually started with, we built a whole V1 system around Pulsar that we ended up tossing because we just couldn't get the query performance out of, you know, we thought, well, of course we're going to use a queue. So we'll soak up all the data with the queue, and then we'll just query the queue. Right. And it worked, but your queries are so slow, and we could do the kind of complexity that we wanted to do. Like that was okay. You know, you could express just about any level of complexity of query and you'd be able to satisfy it, but it just took too long. And so we did a prototype with the Trino memory connector of all things. So I was looking around, as like we'd already picked Trino, and so we asked ourselves, well, what's kind of the speed limit? Like what's as fast as we could possibly go? And we'll see what that teaches us, and then maybe we'll work backwards from that. And the fastest thing that we could put our hands on was the memory connector, which I know is kind of a atypical use of that, but we actually did that, and yeah, you paid a ton of overhead in processing like the insert statements, literally bulk loading the insert statements into the memory connector, you'll burn some CPU in doing that, but worked just fine. We were able to do the same kind of data capture that we'd been doing, and the queries that we were getting were just ridiculous. 100 milliseconds, 200 milliseconds, 400 milliseconds, and we saw this, and for the first time, we really went, wow, like if we could make that real, if we could deliver that kind of performance up through our UI, when you click on show me the API attacks, and we're giving you that data in less than a second. That really felt like we were onto something. But now as engineers, we're like, great. So how do we actually pull that off?
So can we step back for a second? The memory connector, maybe Martin can tell us what this is actually designed for, because it's actually pretty much a hack. So, and you're building like a full-on real system on top of a hack there. So let's talk about that house of cards a bit.
Yeah, memory connector is primarily for testing. It's to be able to test things quickly without having to have an external Hive or database or anything like that. So you can launch a Trino instance, try things out, make sure your queries work, and that's it. And I think we use it in some unit tests, but that's about it. And
I used it for my demo queries when I wrote the Trino, the definitive guide. I wrote it for like people that just want to fire up Trino without attaching anything. You can write a create table into it and then learn SQL with it, right? Like if you want to have custom data. So it's literally a playground.
Yeah, but for example, if you have a cluster of machines, each of the machines has a segment of the table. If one of the machines goes down, then your table is gone, right? So there's no redundancy. Well, but I mean, you can have memory, but you can have redundancy. You can have like segments be replicated, moved around, and all that. There's nothing like that in that connector. People have been talking about improving that and making it a real production grade connector, which is interesting and is something we should pursue.
Yeah, I think Netflix mentioned something about that at some point. I think it was on the last show, or maybe it was just directly to me. I'm not sure. But
I know that in development, it's used pretty heavily also for testing out things like, like figuring out like things on like dynamic filtering or push down and whatever, because it's so fast and it has all the bells and whistles of a fancy connect. It just doesn't have the headaches of a storage attached. So, well, it has in memory, but it's kind of cool.
Yeah, and it just happened to be perfect for the kind of prototyping that we're doing, because we don't really do updates. We do bulk deletes. So even something that just does inserts and selects is really all that we needed. So yeah, I mean it was originally like literally just a prototyping effort, but we were so happy with it in the end. And part of what we do is we start everybody with a single container instance, which I think we'll get to here in a second. But we actually ended up shipping that for a few months, that version, knowing all its limitations, right? And it's funny because you always feel a little weird if you're using a tool in a way like it obviously was not intended to be used. But I just loved the first conversation I had with Martin about this. He was just kind of like, yeah, I mean, I guess if that works for you, I mean, I guess it's okay. Like, and just kind of went with it. So yeah, it's awesome.
Yeah, Martin was definitely pointing at the part in the Apache licensing saying that we're not responsible.
Yeah.
But no, so what then pushed you on? Like, I mean, you're saying V1, so I'm guessing now we're on a V2 type version. Could you talk a little more about kind of the progression there and what you all do today?
Yeah, and so once we had this running on the memory connector, and like I said, we'd been on Trino for a while to that point, because we always had this idea of wanting to support SQL clients and be able to support any kind of SQL tool or ETL tool or dashboarding tool that a customer might want to join this data on. And so now that we think we've got the performance that we might want with something like the memory connector, now it's like how to make that shippable, how to do it for real, how to position that really to work in a larger scale out environment. And basically we started with the local file sample in Trino itself, which was awesome because that gives the whole shell of what you need. So for anybody looking to build a connector, that would be a really great place to start. So that gives you the Maven plugin task, just made all of that super easy. I've done custom plugins for other tools. It's not always that easy, but in this case, it was really a copy and paste. We got our first version of our own local connector working in about a weekend. And what we did is first we tried kind of putting all the data in Redis, because we thought, well, Trino memory connector, that's an in-memory thing. Redis is a really good in-memory thing. Let's just put all of our data in that. And the problem with that was you've changed the locality. So with memory connector, all that data is sitting right next to Trino. You go to Redis, now all that data is sitting across a network hop between Trino and Redis. And we're touching all the columns, we're touching all the rows. So it's like you're trying to pull all that data from Redis across the network every time you do a query. Obviously, the network is the problem. So that's why we started really looking harder at things like the local file connector and the HTTP log example, and saying, let's use this ability that Trino gives us to push the queries to where the data lives and take that network out of the middle. And then we tried looking at JSON. We did CSV and protocol buff, and like really what's the fastest way to bring that data in? Is it Avro? And ultimately what we found was just streaming this data to our own binary file format and doing the bare minimum of processing at capture time, and then having a connector that's really built working backwards from the Trino row set interface specifically, and basically brought that together without a lot of impedance mismatch or a lot of translation between that. So we actually tried this with Avro, for example, but we realized with our implementation, we were able to do some things that we really couldn't do with that kind of layering. Our file format is very simple. We have basic versioning. We don't really have secondary objects or graphs that are being stored and reconstituted. We want to be able to scan this data very, very quickly. And so we did a zero allocation reader on that. So basically, as you're reading from that binary file, it's mem copies. We're actually assuming that these binary files are pinned in OS cache, so they literally are, and they don't have to run that way, but in the cases where it is configured that way, it really is, an in-memory database in terms of its operating characteristics. And then looking at the Trino connector itself, that means now that we can do things like reporting null and not null without doing any type of type conversions. So if you think about, like, I'm going to read something from Avro and it knows it's a string, and so it's interning it as a string before I ever touch it, right? Instead of doing that, we're basically saying we're doing this zero allocation mem copy, and then if is null gets called, you look at that particular column and you see if it's null or not. And then you wait until get sliced would be called in terms of strings to do your string internment. But even that, we worked backwards from the slice interface so that we would hand off that buffer without any extra allocation happening there. So don't mean to go too far into the weeds.
No, that's exactly what we need.
Yeah, you think about like everything that you have to go through to parse a line of CSV, or everything you have to go through to parse, a JSON object, all of the memory allocation and scanning and parsing that goes into that, we really wanted to try to eliminate all of that. Yes. and really just take it down to, a few fast mem copies, defer your type conversions. And it's funny because we didn't even realize like how significant that would be at first. But kind of at these latencies that we're talking about here, taking a byte array and casting it to a string is actually a very significant operation in terms of the performance of it. So being able to stick to the slice interface and just say I've got this region, and I pull that out as an array and just treat that as the slice, really just kind of put this on a whole new level.
Wow. So,
I can't say that I spent 6 months trying to make CSV as fast as it could possibly be, or I didn't spend months and months and months trying to make our protocol buff. I mean, maybe there are other ways to tune that up, but our benchmarks, we can get 3 times the linear scan rate with our format that we would with CSV, and there's almost no garbage collection happening during that process. So that's kind of hard to beat.
Yeah.
That's amazing. But that file format that you created is basically optimized to the fact that it's in memory and it's basically geared towards your use case, right? It's not a generic thing, right? Like that's probably one of the advantages you were able to wield, that you can tune it towards that specific use case. Like any other format like CSV or Elasticsearch, kind of like JSON has the problem that it is a string, and then more binary file formats still have the like Iceberg or whatever, like with like Parquet or org files, they have the problem that they have to be generic. You really could gear it towards your use case of like logs and like payload, right?
That's absolutely right. We're totally cheating from that perspective.
Well, I
right?
mean, that's not cheating. It's being smart, right? Like
but you're absolutely right. Like Avro, Park, Ork, Parquet, switch that. And Redis 2, they are all trying to solve, they're trying to do their best to solve this for any schema, for anything that you could come up with that fits that model. And why we're cheating is because we can make all these specific assumptions around our data model specifically, and that's where, I think in general as a database developer, there's always that last mile to think about of having a more domain specific model, and if you can get a more native expression of that somehow in your data store, that can really be a way to move the ball, when all else fails. But you're exactly right. So our format is really geared to our definition of and the HTTP definition of what those data elements look like. And then a lot of that, actually so much of that, is done through views and through virtual columns. And it's funny because when we did our V2 project and we did all this stuff around Trino, we were really just thinking about optimizing our query performance and our read performance. But through that process, we actually realized that we didn't need to write as much data, which was crazy because we weren't really out to optimize for the writes.
So that leads me to.
But we moved so much into the virtual columns. We just didn't need to do a lot of that stuff at capture time.
So you actually ended up losing, or like you end up dropping some of the data that's coming in from logs. Is that what you're saying? I'm not sure if I misunderstood that.
Well, so yeah, let me take another stab at that. So let's take performance thresholding as an example. So you might say, let's define a threshold, and if it's more than 15 seconds, it's a timeout. And if it's less than that, or whatever the bucketing you want, kind of the traditional way to do that is score the data as it comes in, because you know what the response time is. So just have a column for that and just put a category on it, and and then you can query on that category and you're good to go, right?
Mm-hmm.
But the problem is, well, what if the customer wants that baseline at 12 seconds or 25 or whatever? Then you'd have to go back and reprocess that data.
Gotcha.
So for those kinds of categorizations and scoring, anything like that we can do at query time, we're actually doing at query time.
Gotcha. Okay.
And we ended up writing less data in the process, even though that wasn't really our goal.
Gotcha. So you're keeping the original columns and fields like that you derive, that you'll use to derive those metrics, but then you're just kind of avoiding. You're doing more at read time versus as much at write time, and I'm guessing that's a tricky balance.
It is, and that's where the views functionality in Trino has really saved our bacon, because what you end up doing is we have some intermediate views where basically we hide a lot of that together. So think about, you've got the table format that the Trino connector exposes, and then on top of that we put a message view, and that's what gives us all those virtual columns that we were showing in that list that we had before. Then on top of that, we put predefined views. That's like, now you're getting into failures and threats and slowdowns. And then on top of that, you can put custom views. And with Trino, like, the custom views can inherit from the base views. You're not limited in that kind of inheritance or composition. And it's really amazing. So it's been, if there's been any theme in what we've been doing for the last 3 months or so, it's really been just rethinking everything that we were doing at capture time, and saying, is this faster to do at query time? Is it better? Is it more malleable to do at query time? And so far the answer in most of those cases has been yes.
Especially if it's like exploratory and you're not, returning everything, right? If a customer is only looking at, let's say, a couple hundred rows at a time or something like that, that's ridiculously cheap, much cheaper than trying to optimize everything all at once on ingest.
So I have
absolutely.
So I have a naive and like also semi-practical question from a Trino perspective. Then Trino is a query engine. You run the coordinator, you run the cluster, and now you're slapping your storage system into that. What does that practically mean? Like, how big do your nodes have to be, and where do the files actually get saved? Like, are they like distributed across all the workers, or is that some sort of like mounting of like a shared drive or whatever where you're writing? Like, how does this actually work? Because ultimately the files are not just sitting in memory over time, I guess, since you're saying it's a system of records. So it must go somewhere over time, right?
Yeah, they do eventually page off. And we do, what a lot of folks want to do is they want to have a backlog of a certain amount of data or a certain amount of months of retention, and where the data will eventually page off, or it will page off to cold storage. So you could think about those binary files going out to S3 and being able to bring them back later. That's
okay.
Kind of,
so they
that's
stay
kind of
in your file format, and then they bubble over into storage. But initially they just sit on the workers.
That's what we're doing for our first cut. Martine's given us some ideas to consider about what our next generation connector might look like. But our first stab here is we're assuming that the binary files live local to where the worker is running. So so I think the better way to say that is there's one split per worker. So we're using that pattern that you see with the HTTP log example, and then but it still gives you the distribution, right? Because as long as you're evenly distributing the traffic across those, then you can do a distributed query, and you're getting the data back from each node. And for our, I know that's primitive and a simple way to look at it, but that's actually working for us quite well. And then I think the next step for us is to go to a multi-split per node kind of architecture, where then we're parallelizing the reads to those binary files instead of processing one job per node. So I think we found an easy way to get started that's producing some good results, and then we can parallelize the hell out of this thing in the coming months and really be able to take it to a whole new level.
But any data for any payload only is on one node, right?
For right now, yes.
Okay.
And actually, I loved when Dane asked this. He got this question in one of the recent meetups about why don't you have HA in the coordinator? And if I had to give the answer, I would give exactly his answer. The answer that he gave was that people don't want to pay those extra dollars for all that extra infrastructure that isn't doing stuff for you most of the time. Like it's better just to have a way to recover the node than to necessarily make everything redundant. And we're really applying that same logic here. So you think about, like, I've got one of these nodes, I'm writing files. Those files are probably getting mirrored off to EBS. If that node fails, I just need to bring the node back. I just need to get access to what's on the EBS again. Mm-hmm. And if that's off for a little while, that's okay. I can bring it back. And our customers would really prefer to have that lower cost approach than to spend a lot of extra money on the redundant
on yet another 9.
Yeah, I mean, there's always going to be folks who are willing to pay for the big 9s, but there's not, I don't know, but when you really give them the option, if you give them the choice, a lot of them will pick the cheaper one and roll the dice, and that feels right to us.
Yeah, that's very cool.
Very cool. So I think getting into where you guys are right now, you have this last kind of visual showing, how you all have structured this. So is this resurface database kind of the NMEM that we were talking about, and then Trino here is the other data sources, or what's this part telling us here?
Yeah. So the message that we're giving to our customers is that this is a turnkey solution. We're not a big data platform where, like, we give you the platform and then you have to adapt it to a specific use case. We're trying to give you a turnkey solution specifically around having an API system of record. And so we can start with a single container version of that. We can go to a multi-container version of that. And what we're showing here is really what we think is the next quantum leap of that. This whole conversation that we've had here today is about using Trino as a primary data store, or as your primary data architecture. But what we want to move to is a picture like this, where, well, now that you have that API system of record, well, what can you do with it? It's great that you can take that, you can connect your data notebooking tool, your machine learning people can use it. You can pipe this into analytics, or you can bring this into ETL and bring this data into your data mart. Like, that's great. And that sounds like Trino. Like, the more you start talking about that, that's Trino. So this idea now of being able to take this API call data and merge that data with data from other sources, now we're actually getting the full value out of the Trino Starburst platform. Now I can start to talk about reconciliation cases where, let's say your OLTP database is Postgres and you've got your system of record on the API side. Well, now you can do a reconciliation and you can say, were there any order attempts on the API side that didn't actually result in finished orders for those customers? Where's that subsetting, and where's that lost revenue? And I think that's just a whole nother plane for us to be playing with. And I think, as I said, that's where I think we'll bring in the whole value of of the Trino ecosystem and all those other data sources out there. And that's the direction that I'm really excited about. Like as much as we're super fans and we've used Trino as a way to build our system, that integration story that Trino has with is still our North Star, I think, in terms of what we're looking to do.
Yeah, you could really do, like, even you were saying like reconciliation in terms of like finding out how many lost dollars, but then even if you, let's say just something like you had garbage data or that garbage call, and like put some CRUD into a couple rows of your system, and you want to identify that, like what are the calls that resulted from this recent attack that we had. And this would be a way that you could easily kind of address that across different data stores. So it's really interesting.
Absolutely.
Now I have another question. It's a bit back to the technical stuff we talked about first. I love the idea how you're like going from the like bare bones binary files, layering a view on top, layering another view on top. And that gets us to a question that talks about views, because views is something that we're actually going to be talking about next week as well.
Yeah.
And I want to understand maybe from you and Martin, how does this even work? Like, where are these views now stored? Like typically, if you define views, they have to be stored somewhere, right? So are they stored in a Hive meta store, or like, how does this work in your case and generally in Trino for this, where you like have a custom connector and now you have views? Like, where's this, like, I know it's a binary blob that defines the view, but where's this stored? How does that happen?
Well, let me talk briefly about views. So views are like any other entity in a connector. They are just like tables. So, but instead of having metadata that just says these are the columns and the types of the columns, it also has the definition of the view. So there's an API in the connector interface that Trino will call to say, give me either give me table metadata, or if it's a view, give me the metadata for the view. So it's up to the connector to decide where to store it, how to store it, how to manage it. The Hive connector is one example of a connector that can handle views and can store views, but any connector can do that. And imagine, maybe Rob, you can talk about it, but I imagine your connector does that, right?
No, but I'm going to put it on the list. Sounds like the right way to do it.
So how are you cheating around notes now then?
We're using the memory connector.
Oh, so the memory connector can store views?
We are now. I'm curious to see how you guys cringe when I say this, but yeah, we're still using the memory connector, but we're only using the memory connector to store those view definitions. Mm-hmm. So if we lose them, it's okay because we can recreate them. The actual data,
static, right?
Yeah, they're fair. They don't change that often. You can change them on the fly, but it's really like that's not something you're doing continuously. But I love the idea of actually being able to manage those through the connector and not having to require the through our connector, sorry, and not having to require the memory connector for that.
Yeah.
Well, and one thing is that the views don't actually need to be stored. They could be synthesized. For example, you can say, you were talking about the view that does thresholding. So you can synthesize a view that has as the definition has a synthetic query that you derive on the fly. When Trino says, give me the definition for this view, then you can say, well, I'm going to assemble a query at this point and return it to you as a view. So it doesn't need to be stored anywhere. It could be like, for example, if your customers are going to a system and saying, I want to set my threshold to this, my threshold to that, you could go and query that system, look at the thresholds, and then synthesize the query that will enforce those thresholds and then return it as a view.
That's far out. Yeah, awesome.
And so the memory connector, Martin, has a configure, like has that built in that it can store those views.
Yeah, it's just an API. It's like a create view and get view definition or something like that.
And in the case of the memory connector, as anything else, it stores it in memory, right?
It's just a map. It's just a map that says for this name, this is the definition. So it's pretty trivial implementation.
Oh, that's pretty cool.
Very cool. And
yeah, and it's really, and we think about like and I don't know if this is completely the intended purpose of this, but we're looking at the memory connector as like I can connect to that, like the views that are defined there. Well, the data underneath that could live anywhere. So that's where you could really say, like, you've got this one set of views, and sometimes there's this data system behind it with one container, and sometimes there's this system behind it with umpteen containers behind it, and you really can't tell the difference. Like, you're still running literally the same SQL against what you think is the memory connector, but the data doesn't actually live there. It's all been virtualized out.
Yeah.
Very cool. Okay. Well, Rob, was there anything you wanted to kind of like touch on, finalize before we hop onto our PR of the week? We're at just over an hour, and so we're probably needing to wrap up here in just a little bit. But was there anything you wanted to kind of mention about how do people, I guess, find out more about Resurface and and anybody who's interested in kind of has APIs that they need to keep the consistent pen testing going on? Where do they find out more about that, and how do they get in contact with you?
Yeah, so if you've got an API and you're like wondering like where's the Google Analytics for my API, where's like the equivalent of that, where's the mix panel or that equivalent in API land, that's really the role that we're trying to fill, and doing that with a real DevSecOps flavor.
Yeah.
And you can find more at Resurface.io.
Okay.
We have a free pilot edition, which is a free forever version. It's download and go. It's a very small container. It's a 250 meg download. So we're actually going to do a post on how we got Trino down into that small a footprint.
Wow.
I have some ideas about that.
Which was easy. Actually, wasn't that hard. Yeah. Maybe we could trade some notes on that.
Cool.
Maybe there's things we missed. Yeah, but we'd love to get your feedback, and lots more of good stuff and use cases over at Resurface.io.
Y'all have a Slack and a GitHub. I'm going to add those to the links. Any other way that folks can kind of chat, hang out with you all, and
I know that he's also hanging out on the Trino Slack.
Oh,
so
always.
You can find him there.
Yeah.
And you can also go to the Trino.io website. Right on the front, there is all the user testimonials, and Resurface is right there as well with everything. So right from the Trino website is as well possible.
Awesome. Well,
yeah, really appreciate the support.
Yeah, we definitely appreciate your support. It's definitely very mutual. Okay, so with that, let's hop on to the PR of the week, as well as the question of the week. PR of the week is one that came in the most recent release, so we do get to still talk about 356 just a little bit. So a big shout out to Toop4, is one of the members of the community. We don't actually know their name or anything like that. We've just known them as Toop4, and on Slack it's T. So, but they're very prominent in the community. Adds a lot of great features like this, and this is just one of those examples that Toop's been adding. So, so this is adding a phonetic functionality. It's a lot of fun to play with. If you don't find an actual use for it, you need to just like open up your Trino CLI and just hack away at this for a little bit. It's loads of fun. So I mean, actually, Martin, you were explaining a little bit about this before. What is the Soundex function? What is it? Where is it from?
It's an old algorithm. I think it was popularized by Donald Knuth. I think it's in the art of computer programming.
Okay.
I don't think he created it, but he definitely talked about it. It's actually a pretty simple heuristic algorithm, and it's designed for English only. I think it does things like takes a word, keeps the first letter, then removes a bunch of consonants and vowels, translates a bunch of letters to numbers to canonicalize them, and then gives you a result. So any words that tend to sound similar end up producing the same results. So it's a kind of a good way to see, like, if two words is a way to query for things that might be misspelled, that sound the same.
Okay.
Or should sound the same.
Gotcha. So let's take a look at this. I looked at the example that was in the drill documents, and it kind of uses this select first name from name data, and then you just kind of compare first name to Jamie. So I made a couple of these for each of the folks on the call here today, obviously myself. So let's go ahead and pull up. Actually, I think I have it over here. Here we go. I have all these already copied over here. So we have a big list of names that we're pulling from: Bree, Brian with a Y, Brian with an I, Brian with two N's, Brianna's, Jan, which, by the way, Jan, if you're on today, I was trying to see if I could get Bry and Jan. We have a Polish name Jan, which is Jan. So assuming that this is English, it's not going to probably return the Jan. But if I put Bri space Yan, it's more likely going to say Brian. So and then we have Bob as a very outlier test. So what gets returned is Brian with a Y. And by the way, I do a where Soundex name equals Soundex of Brian spelt with my name with the I. So obviously we expect that the Brian with an I gets returned. Brian with a Y also gets returned. Brian with two N's gets returned. Brianna somehow gets returned. So I'm guessing that that's due to the fact that they removed the vowels. So Brianna, the in Brianna gets lost, and so it's just Brian again. And then Brian, but unfortunately, Jan and the Polish pronunciation does not get caught in there. So some things you might expect would work maybe in different ways that you pronounce the words based on your own dialect might change. So I had Manfred, a couple from him. So I had Man, and then Fred, and then Manfred, and then Can-Fed, and then Tan-Bed, and then Man, and then space Fred, and then Man space Dread, and then Bob, of course. We had to keep Bob. So let's see which ones get returned from that. So it's just Manfred, all one word, and Man space Fred. So those were the two that worked. Didn't keep Manfred, Tan-Bed, Can-Fed, none of those stayed in.
Can't be forged that easily, haha.
Exactly. Martin was a bit of an interesting one. So, we all know Martin's coming from Argentina. So you don't say it Martin like you would in the English pronunciation. So I was thinking that I wasn't sure about how the algorithm worked. So I thought maybe Martin, if I put MAR space T and then like the word teen, like a teenager, was not going to work. But let's do a quick call here and say, surprisingly, Martin, with the vowels removed. Now that I know that that's the case, now that the vowels are removed, you actually get that equal. So Martin and Martin. So I put Mart and IN. Those all get returned. So pretty much everything that I tried for Martin's name.
So I have an interesting suggestion there. I think Martini, the drink, would also be returned as true.
I believe so. Let's give it a shot.
It will,
yeah. Martini. We just
have to find out if that's your favorite drink.
Yeah. That's Martine's new nickname. No, I'm just kidding. Yep, of course it gets returned. And then for Rob, we have all the various, I put Robert, Rob, Bob, Bobbert, Bobby. So, and the only one that comes back from that is Rob. So, because obviously the consonants changing, I think, is what this algorithm will detect. And then we have a special guest that has not been showing up on video, but she's on us here with Zoom. Christine is one of the other co-founders from Resurface. I also used her name, and I didn't put an ID here, and not like it matters. But I found some interesting ones here. I was hoping that the Christine with a K would match the Christine with the CH. So when I ran this, and this is again before I knew that it was just like removing vowels, that Christine with a K didn't show up. So depending on how you might think to use this. It wouldn't work if you're just trying to kind of find the exact phonetic matching. It's much more simplistic than that. So now that I know that's what this function is actually doing, let's actually take a look at what this function is returning. So let's go ahead and pull this from, and we can just do select Soundex name and actually see what we'll do name as one of the parameters, and I'll add these to this. I'll add this to the show notes, but I believe this will actually give a lot of insight as to what is actually happening here. So that's ultimately what these things are getting returned to. Is you keep the maybe at least the first initial, and then somehow it's taking these different values. So that Christine starts with a K. You know, if I wonder if I bet if we put Christine.
I was going to suggest, Brian, if you open up the Wikipedia page on Soundex, it shows what the heuristic is. It's actually pretty simple.
Oh, okay, let's see, Soundex wiki. There we go. Okay, so retains the first letter. Oh, it retains the first letter. There we go, of the name, and then drops all other occurrences of vowels. Oh, wait, not just vowels. A-I-O-U, but then also Y-H-W. And then replaces consonants with the digits as follows. And then it gives B, F, P. So particular consonants will get mapped to a particular number. And then, yeah, okay, so that makes sense.
It's not just sort of special for English. It's also special for like American English or so.
Yeah, for sure. Oh wow. Okay. So yeah. So anyways, we'll I'll add that Wikipedia page as well as the select query that is actually pulling out these values next to the name, so that you all can play around with the Soundex function. It's a fun little thing to play around with. I don't know. I'm struggling to find any real production use cases for this, but I'm sure there are some. I
think it's a good example, PR, for anyone that wants to implement another function. Like, you know, there's lots of use cases for implementing functions, and this shows you sort of like how to hook in a new function. And also recently we just added a PR that also got merged 2 days ago by Martin to have the documentation for it. So those together can give you a pretty good clue if you have any functions that you want to sort of add to like find the right hooks basically to get started. And then obviously depending on the function, it can get a lot more complicated, but those are a good start.
This PR was, I mean, relatively straightforward. It's mostly actually dealing with pulling in the Commons codec library. There's Tube didn't necessarily go on and adjust or create this function himself. He just pulled from I'm guessing this is Apache Commons.
Yes.
And it's using the Soundex function and basically just passing down the string slice into the algorithm and then returning the slice back. So it's not that hard in terms of code, but you know, something like this, especially because if you think about anything under the sun and the Commons library, they have a whole bunch of functionality that may even be useful for SQL queries, not even just this one. And there's a whole slew of other phonetic functions that could be called here. So anyways, very interesting PR, and just one that, again, shows some easy ways to contribute, especially if somebody has a real particular need. So thanks, Toop. And then the question of the week, let's move on to the question of the week, and we'll finalize the show, is how do you export query results into a file? So a lot of folks do CTAS, which are the create table as type queries, to where you're trying to kind of move data from one connector into another connector. But then a lot of folks get a little stumped whenever it's trying to just get it out into a file. And so there's maybe some change or updates that we need to do on the documentation here. And maybe add a little more about this specific execute functionality. But you would use, there's one example that is on the Trino CLI documentation that shows it, but it doesn't really go into too much detail as to talking about how to use it and how it could be used to kind of export. But does also show this output format here, and then we talk about the different formats here. So maybe a little bit of cleanup that could be done here in terms of the documentation, but to show just like all out how you would do this, you would basically use your CLI executable and use this -- execute function to encompass some sort of querying. And so in this case, we're just going to query the TPCH customer and then just pull out 5 rows. You'd specify a server. I think by default, this is going to be localhost 8080 anyways, so you may not even need this. But and then you have output into whatever format. And in the show notes, I've outlined the different formats you can do. You can basically have aligned and vertical, which I think are just text-based, like the kind of how you would expect to see it in exporting from the CLI standard out. And then you also have like tab separated, comma separated, and then JSON are the other options that you can do. And by default, it spits it out using CSV without the header. You also have these TSV, CSV header options or unquoted as well. So anyways, let's go ahead. I'm just to do a quick run through of this. I have my Trino cluster running in a Docker system. So I also included a quick Docker run version of this, and I'll just quickly run this and show what this looks like. So we're sitting in here. We just basically need to run a temporary TrinoDB Trino container, and it's going to connect to the existing network that I have that's running. And then I'm going to just execute. All it's going to do is execute this Trino command running the CLI, and then ultimately spit it out. I've changed instead of localhost, it's actually pointing to the internal name in Docker that I have. So it's Trino coordinator. So we run that. Take it a second to actually pull up the container, since this is actually doing the Docker thing. And then we have this local file here, customer CSV. We can just got that out, and yep, there we go. We have with some headers, and we have the CSV. So that's that. It's pretty straightforward to actually just spit that out and do a little easy file. I guess hand a file off to whatever other process you need to ingest it.
Two additional tips I can give about that.
Sure.
First one is the -- execute allows you to execute a statement. Basically what it does is it calls whatever and then executes afterwards, right? Like the Trino command will exit and finish. If that SQL statement is any longer than that little statement that you have there, you can use the -f function or option to feed a SQL file in it. So if you have a long SQL statement, then you feed that SQL statement from the file into it. And then as a hack, yeah.
To add to that, Manfred, that's useful if you have queries that have double quotes or quotes, and you don't want to deal with escaping quotes in the bash command line.
Very, yeah.
Exactly. So the typical thing is to use a file, and then since we talked about the memory connector with Rob today, an example on how I use this in the Trino the Definitive Guide book, we used it to insert the iris data set into the memory connector to write queries with. So in the book that you can download for free from Starburst, and the example repository is also in the Trino org, there is a query that uses exactly that approach, which does a create table as into the memory connector, which inserts the iris flower data set that you can use then to do analysis and stuff like that. So
cool. We'll add those
right there as well.
Yeah, we'll add those examples as well into the show notes, and maybe at some point this could be something we'll use to get into the documentation. So
sure, sounds good.
Cool. All right. Well, I think that's about it. Thanks everyone, and thank you so much for joining us today, Rob and Christine. And hopefully we'll be seeing those updates and basically have the full Trino analytics system running underneath Resurface here shortly.
Yeah, let's do it.
Awesome.
Thanks so much for having me. This is a blast.
Great. So
awesome.
Music for the show is from Mega Man's 6 gameplay album by Krzysztof Slawikowski. Have a great day, everyone.